Good morning and welcome to our latest FTW webinar. Today, have a good one. This is fiber optics for AV professionals, and that would be you guys. So we're going to do the understanding the what, why, and how. We've got a really interesting presentation that I've learned a lot in watching the previews of it, and so I'm hoping you'll enjoy it. I hope you share it with some of your coworkers. Cameron Smith, who's our presenter, is going to take us through a lot of detail that'll help you get positioned for dealing with fiber optics and installations. But before we get to the presentation, a couple of things to be aware of. We have the program being recorded, so it will be available to either yourself for a review, or if you have coworkers you'd like to share it with, please direct them to our website. The FTW website has links to all of the recordings of this and all the other webinars that we do. For questions, please use the GoToMeeting question functionality that's built into the software. That'll appear on our screen. We won't interrupt the presentation for the questions, but at the end of the presentation, we'll always pause to reflect on any of the questions that have come in and try and address those. So I'll be the clearinghouse for those questions and just type them into GoToMeeting, and we'll make sure that those get addressed. And then finally, there is a survey that we would appreciate if you could fill out before you leave the webinar. As you exit, please do that first. That helps us a great deal as we try to tailor these webinars to meet your needs and be as interesting as possible and not miss the target. Your direction helps us. And along those lines, after the last webinar, someone wrote in and said, well, I got clued into this webinar and I watched it and I enjoyed it. What I need to be clued in about is what is FTW. So they were new to FTW and they didn't understand too much what we were about. So I don't want to make a big commercial out of it, but it is important that people understand FTW is a wholesale distributor company, and we are really focused on the contractor integrator market. Certainly, we sell to a lot of different customers in the resale environment as well, but the prime focus is in the integrator contractor market. So the topics for our webinars, we try to pick topics that we think will be useful in terms of explaining new technology, enabling contractors and installers to embrace some of the things that are changing in the industry, the new standards, the new technologies. And so today's presentation is right along those lines. So now that I've done the housekeeping, let's move over and meet our presenter today. Cameron Smith is our presenter, and not only is a very good person to fill you in on this topic, but he's an old friend, and he has helped us on other technologies over the past. As you see on his screen, Cameron has had a distinguished career working for a number of companies. TechLogix, which at one point was even a sister company to our parent company, was very involved in a lot of the emerging technologies that went around the use of balins and extenders in the industry. And so he was teaching us about those kinds of products when that was the emerging technology. So I find it very, very fitting that he's also here now in this age of a much more sophisticated distribution and extender products. And I guess you can think of fiber as an extension interconnect type product to help us with the underpinnings of that wonderful technology. So Cameron has formed his own company, CEO TechLogix Networx, and they have become a major supplier of fiber and fiber related equipment to the AV industry. And with that, Cameron, let me turn on your microphone and get you on board with us here this morning. First of all, thank you for joining us.
Yeah, appreciate it. Thanks for the invite. And I'm very happy to be here. Very happy to talk about fiber. This is obviously a hot topic for most folks.
Well, it's one where everything is not intuitive. It does pay to go to school and all a little bit, and you're a good guy to be the teacher. So I'll back out and let you do that. We'll come back with questions at the end of this.
All right, sounds good. Thanks, Kevin. Couple of things that I'll mention. So yes, this is a presentation about fiber. We're going to be going through one of the decks that TechLogix is very instrumental in creating. Now you see CD on here. This is by no means a residential presentation today. It just so happens that this is an accredited presentation that we put together with the CD organization. I liken fiber to HDMI, at least what we're seeing with the technology and kind of how it penetrates the industry and how people are starting to work with it. And for folks who've been in, kind of the AV world as long as I have been, we saw how consumer electronics grabbed HDMI, and then over a couple of year period, it really started to move into the commercial side of the business. That's not to say that there's more applications in one industry or the other. We actually do more work in the commercial marketplace. But this is a fairly agnostic deck that we're working with. One other thing that I'll mention before we jump into this, there are 2 handouts. If you want more information on some of the fiber optic definitions, there's a great cheat sheet that's going to go through a lot of the different things that we're going to talk about today, as well as a solution guide that'll kind of walk you through the technology. So with that said, let's jump into the content here. Again, fairly agnostic. So from a very top level, what are we seeing with fiber optics? And, I do these presentations quite a bit. We've got other folks in the TechLogix organizations that do a lot of trainings, literally around the world. And very often we have a mixed audience. And often the folks who are sitting here working with us, spending 45 minutes to an hour to go through the content. And, a lot of the times we're doing these, in person, hands-on, actually teaching them how to terminate. It's a little hard to do that while we're sitting on a webinar, but a lot of questions come up. And often one of those questions that we get is, why are we doing this? I installed fiber 20 years ago. I installed fiber a decade ago. What makes this time different? Why are you telling me that I really need to get into it? And the content that we're going to look at today is really going to answer a lot of those questions. But the punchline here is, fiber is the future of AV. Most people on this call today, we're all AV professionals. We're doing integration work. We're doing design work. We need to think about fiber and how that really impacts the way we're engineering our systems, the way we're installing our systems. Keep in mind that obviously everything that we do has to be efficient, it has to be profitable, it has to actually have a real world application. And fiber, by virtue of what it offers to us in terms of distances and bandwidths and ease of operation, it really checks a lot of those boxes. So the future of AV has a really strong bond with fiber optic cabling. And for folks who aren't used to this, or this is really new content, the good news is the ecosystem really isn't that much different than the ecosystem we're used to working with. And what do I mean by that? So if we look at a twisted pair, right? We all been working with copper-based cables for years and years and years. Now we're talking about optical-based cables, glass, speed of light, lasers, right? That's what we're talking about with fiber. The components in that fiber ecosystem aren't that unfamiliar. They may be made of glass, they may have lasers inside of them, but we still are dealing with things like bulk cable, right? We pull that cable, we terminate it in the field, just like we would with a twisted pair cable. We're just doing that with a fiber optic cable. Patch cords. This is an interesting one because we think of patch cords. I have a rack, I need to put 2 pieces of equipment together, patch my network switches together, stack those switches, or if we're in the copper world, we're talking about AV equipment. We have little HDMI jumper cables that we're attaching to our equipment to make it all work. Well, we think of patch cords as typically a shorter length cable, but in the fiber optic world, we're dealing with some pretty long lengths. And this was an area that really surprised me in our business. We're building patch cords, or, we call them pre-terminated cables, for literally miles in length, because you can do that with fiber. And this whole concept of give me a pre-terminated cable that's ready to pull for my 300-foot pole, my 400-foot pole, whatever it may be, up to 20 kilometers, it's a very interesting opportunity that fiber really presents. We can handle these big patch cord type deployments. Specialty cable, right? Direct burial, tactical cables. Tactical is an area that we're really seeing exploding because of some things we're going to talk about here in a minute. But you get into specialty variations of the cables as well. Obviously, if we are working with cabling, we got to have wall plates and accessories and connectors and termination equipment. All of this plays into the ecosystem that we're working with. And one of the nice things about the ecosystem, the parts, the accessories, tooling, is we've really seen the price decrease on fiber optic technology over the last 3 or 4 years. And that's compliments of the IT world. We're seeing these transitions from copper into fiber optics, and this is happening all around us in, other vertical markets like IT, like datacom. Us as AV professionals, we can really take advantage of that. The most important and nearest to and dearest to my heart on the screen right now, on this slide, the electronics. Those folks who pulled fiber 10 years ago, 20 years ago, right? Put it in the buildings, put it in the homes, wired up our businesses and our commercial projects with fiber, didn't really use it because there weren't a lot of electronics that worked with that fiber. And frankly, we didn't need electronics to work with that fiber. Twisted pair cable worked great. It had enough bandwidth to really handle what we were throwing at it. The electronics are really what's driving the deployment of fiber. We have things to connect to that fiber optic ecosystem, whether it's networking equipment, whether it's AV equipment, things like extenders and splitters and switches. There are components now for fiber, and that makes the system deployable. Obviously, you got to have a real system approach to being able to work with the technology. Fiber is there now. So let's talk about why fiber. Okay, why are we seeing this? Why are we sitting on this call right now? Well, a lot of the why has to do with bandwidth. And anybody who's been in AV, we've seen this slide before, right? We've seen this transition from 4:3 aspect ratios. We got into 1080p and 720p, so these 16:9 aspect ratios, high definition, right? And then we see 4K. And today, most people who are installing AV equipment, they're fairly proficient with 4K because most of the video manufacturers, think of projectors, think of flat panel displays, they're building 4K displays. That's the standard now. They're discontinuing a lot of the 1080p lines. We are talking about a 4K world. Now, 4K is an interesting thing because if we look at how we've moved those signals, traditional technology has worked pretty well. And the magic number that I throw out on the screen here is 10 gig. And 10 gig is a really important number because 10 gig is the ceiling of twisted pair cables, most twisted pair cables, right? Whether we're talking Cat 5e, Cat 6, Cat 6a, these all max out at 10 gig in bandwidth. Now, 4K, most of the 4K we've worked with, some manufacturers call it 4K 30, some call it 10G 4K. That can go over a 10 gig signal or a 10 gig cable, no problem. So twisted pair has worked great. 4K 60, some manufacturers call it 4K 60, some call it 4K 6444, HDR. The punchline here is depending on what you're doing with your 4K signal, what the color space is, what HDMI version we're working with, whether or not we're enabling HDR, those 4K signals can really quickly exceed that 10 gig line. And actually, a lot of the signals that we're moving around now in high definition applications, they are exceeding 10 gig. And this is not to say that we can't use Cat 5, right? Can't use Cat 5e, Cat 6. We can, but we can't send those signals natively. What we're seeing in the technology, and TechLogix is frankly no different, right? We have what's known as VLC processing. These are chips that go inside of your twisted pair extenders, and they look at the signal and say, hey, if you're more than 10 gig, we're going to compress you down. We're going to take your signal, we're going to compress the color space, we're going to broadcast it over that 10 gig cable, that Cat 5e or Cat 6 cable, and then we're going to blow it back up. So you're compressing your signal for transition. It works. Not ideal. There is compression. You will see, things like banding in the color space on the screen, right? But it works. You get your signal from point A to point B. But now we have a problem, okay? 8K comes along. And 8K is a real thing. We have been seeing 8K displays now ship for over 6 months. Most of the big manufacturers of displays and projectors, they've got their 8K models out on the street. Okay, 8K cameras. We've had cameras creating content, creating video pictures. Super Bowl, right? I use the Super Bowl as an example. People who watched the Super Bowl, you saw what an 8K camera can capture. And it's not that you saw 8K on your screen. Every time you saw an instant replay, you're not seeing a telephoto lens zooming in on the goal line or zooming in on the ball. You're seeing pixel density that is finite enough where you can zoom in and pick different portions of the video. 8K is here. And 8K goes up to 48 gig in bandwidth. That is too much bandwidth to compress down below 10 gig to run over a copper cable. You can't do it. In fact, most HDMI cables, when we start to exceed 10 to 12 feet, can't handle 48 gig. We have a problem. And this is usually where I see a lot of hands in the presentations, right? When I'm doing this in, at one of the trade shows or, some of the regional events that we do training at, where a lot of people will say, well, okay, I get it, but I'm not going to see 8K in the home, right? I'm not going to have 8K in my business. My house of worship's not going to have 8K, cameras and projectors, right? So this is kind of an irrelevant conversation. And we see that CEDIA sponsors this training event we do. This was really built around the CEDIA organization, and that is because we are seeing a lot of consumer technology that is moving to 8K. And a very interesting statistic, I'm a kind of a statistic guy, right? I like data. I like numbers, right? And one of the numbers that I took away from CES this year is that about 98% of the displays, flat panel displays, sold in the United States last year were priced less than $2,000, right? There's not a lot of money in flat panel displays anymore. And we've seen this game play out where major video manufacturers, they get competitive with their technology. They start to decrease the cost of the technology. Really, there's not a lot of margin in it for most people. 8K is a way for us to generate more margin, for them as video manufacturers to generate more margin, and we've seen this play out before. So you are seeing 8K projectors, you are seeing 8K flat panel displays. As I mentioned before, there is 8K content. There's actually a lot of 8K content out there. It's just been sampled down for broadcast to the home. So you're getting a 720p, 1080p signal, 4K signal maybe, streamed to your home, streamed to your business. That is all about to change. And one of the big things that we're seeing in the industry right now that's very interesting is 8K is actually the first broadcast standard that is not designed for traditional broadcast. It's designed for streaming. And that's a really interesting thing because when you're streaming your signals to the business, to the home, right, and throughout your applications, it's easier to drop those signals wherever you want them to go, but it also really puts a strain on these networks. So us as low voltage professionals, AV professionals, right, we're talking about fiber optics for our video feeds, for our audio feeds, but we're also talking about it for networking because we've got to be able to create a robust network, an infrastructure that can handle all of this bandwidth. And this is where my presentation turns a little bit consumery because it's not just about that video. It's not just about that bandwidth. If we think about all the streaming that we're doing now, but it's all the other devices that are hitting our network. Think about the average home, right? The average home in the United States, middle class home, 23 connected devices last year. Okay, that's average. That number is expected to double. And what am I talking about, right? We're talking about laptops, tablets, phones, our wearables, like our watches, our thermostats, our security systems, everything, appliances. They now have network compatibility. We're dropping these things on the network. In our businesses, think about all of the equipment that we're dropping on the network. We have to think in terms of creating an infrastructure that is future-proofed for the amount of bandwidth we are throwing at it. And this is the bandwidth conversation, right? There are other reasons, and this is particularly important for us who are in the commercial side of the business, the broadcast side of the business. Why are we turning towards fiber? Well, we're turning towards fiber for some other very important benefits. Immunity is a big one, okay? You're dealing with a piece of glass. Glass is an insulator. Glass is immune to power surges, lightning, static electricity. It's immune to electromagnetic interference, RF interference, right? We don't have the issues that we traditionally associate with a copper-based infrastructure. The example that I typically use is if you've ever done an installation where you've got a bunch of HD-based T, twisted pair extenders, and don't get me wrong, right? TechLogix, our company, we're in the twisted pair business as well. We're heavy in fiber. We're definitely pioneering areas of fiber, but we still sell a lot of twisted pair components. It's just part of our business. If you've ever done an installation where everything works great, you sign off on everything, you get a call, from the business owner a week later, hey, I don't have any video on this screen, right? One of my screens doesn't have any video, or the video on one of my screens, it's flashing. I'm getting dropouts. What's going on? You go on site, power cycle the extenders, everything works fine. 10 days later, you get that call again, right? Why do we see that? Crosstalk, interference. Anytime you trunk twisted pair copper-based cables together, they can interfere with each other. It's an antenna, right? Now you get a little bit of immunity from twisting your cables. That's why we use things like balins for years, but it's not perfect science. You are dealing with a piece of copper that can have interference affect those signals. And as we go up in bandwidth, higher definitions, higher resolution, it only becomes worse. Fiber is completely immune to that. So if you look at the big markets for this, Southeast, where there's a lot of lightning, Southwest, where it's dry, you see a lot of static electricity. That is where we see fiber. Now, the one got you, right? What is the catch here? The catch is you cannot transmit power over a fiber cable. So you got to power your devices. And whether they get their power off the HDMI port or a USB port or a traditional AC port, or you pull up a Siamese cable, right? A dual cable where you've got power with the fiber. You have options there. But that piece of glass is not going to transmit electricity. A big thing that we're seeing, especially in the commercial world, is distances. We are pulling fiber in applications that literally will run miles. One of the biggest consumers of our technology that we make here at TechLogix out in Las Vegas, these casinos, where they will have literally mile runs of video in these buildings. And fiber handles all of that, 0 frame rate latency. It's all real time. That's because we're dealing with lasers. You can go a long distance. In fact, the short distance products, the electronics that are designed really for the short distance applications, they max out at 1,000 feet. That's the short distance in fiber. But most devices, I'll talk through some of the terminology here in a minute as we get into the different parts of the cables and the different types of cabling. But really, these devices are going miles, kilometers, right? We're going a long distance. And there are some other, advantages from corrosion. These modern fiber optic cables, they're polymer coated. That's a big thing that we're doing here at TechLogix. There's some advantages we'll talk through here in a minute. But what that means is you can handle this stuff. You can work with it. It used to be that people were really afraid of fiber. And when I do these live workshops, I'll often ask a couple of questions at the beginning of the session. Who's worked with fiber? So my favorite one is, hey, what do you know about fiber? What are your perceptions about fiber? What comes to mind? 90% of the time, when those hands go up and people, yell out what they know about fiber, it's all negative. It's breakable. You can get shards of glass in your skin. It's hard to work with. It's super expensive. And you know what? Traditionally, historically, that's true. Fiber is a very delicate thing. You're in it for $6,000 to $10,000 for equipment. You got to go through a week-long training. Well, these modern technologies today, they really address that. And folks can get into working with fiber, less than $1,000. The cost of goods has come down quite a bit, but most importantly, you can reliably terminate in under a minute with, literally 5 minutes worth of training. So it's a very different game today. And this technology, like any technology, it moves really fast. So let's talk about that technology here. Let's look at traditional fiber cabling. This will give you an idea of what we're dealing with here. So, these cables from the outside look very similar to copper cables. Once you rip them open, though, there's a couple of different things going inside that's different. So the cable jacket, right, these come in all kinds of different options. Plenum, you can get armoring, which is a really interesting thing with fiber because you can get full, it's called stainless steel helical armoring. A cable that's smaller than the diameter of a pencil that literally can have 24 pieces of fiber in it and be fully, armored, jacketed in stainless steel armoring. It's a very impressive thing when you start to flip through some of the catalogs and look at the different options that exist with fiber. Well, one of the things that you'll see once you take that outer jacket off, and one of the most noticeable things here, is the strengthening fibers. The fibers inside of the fiber jacket, these are usually made of Kevlar. Some manufacturers use aramid, most manufacturers use Kevlar. That gives these fiber cables about a 220-pound pull rating. Super strong. In fact, you have a higher pull rating with fiber cables than you do with most copper-based cables. It's surprising to most people. Once we strip back that Kevlar, and by the way, you use a regular Kevlar shears to do all of this. There's nothing really that hard to work with here. You get into the cladding and the core inside of that cable. And the core is where the magic happens. That's a piece of glass. That glass is what transmits those laser signals, and that's how we can get so much bandwidth, because if you think of how fast lasers move, speed of light, they go pretty fast, and the glass only slows them down a tiny little bit. So we're moving data, we're moving audiovisual signals, whatever they may be, light signals, back and forth very quickly. It's going through that core. Now, what makes fiber fairly interesting nowadays is getting into that cladding and that coating. So traditionally, one of the issues you run into is fiber could crack, it could break. You had to be really careful about how you worked with it in the field. If you exceeded a bend radius of about 30 millimeters, you could crack it. And you were lucky if your fiber broke right away, because what would happen is if you cracked it and it didn't break right away, that crack would slowly degrade over time. That fiber would slowly fall apart over time until it's just unusable. With these modern fibers, they're known as an SSF grade fiber, we still have glass, okay? We still have a core of glass inside, but we're wrapping that core with a polymer. And what that polymer does is it keeps that glass from shattering. So you can handle it with your bare skin, you can terminate, you don't need any protective equipment, it's never going to shatter. You can still break it. And if you break it, it's just going to give you a nice big stick, okay? A big stick that's fully encased in the glass is fully encased in this stick, so it's safe to handle. But more importantly is you no longer have to polish glass, you no longer have to clean glass, and it gives it durability. One of the most impressive things we do in these trainings when we're live with folks, you can tie these fiber cables literally in knots and they don't break. That's how strong these modern fibers are. You actually have a much tighter bend radius. It's a 3 millimeter bend radius. It's actually a bend radius that's smaller than the cable jacket, right? So these cables are stronger, they're easier to handle, and you get a lot more out of them than what we've worked with traditional copper cables. If you've never seen an SSF grade fiber, kind of from a hands-on perspective, it's worth seeing some of the videos on the website here, because we'll actually show folks just how durable these things are. But that is what makes fiber optics deployable, in my opinion, in the AV industry, these modern technologies that allow us to handle it quite easily. Let's look at the construction of the cable. So when you're choosing fiber, it really comes in 4 different constructions. Simplex, which is one strand. So we don't talk about fiber in terms of conductors. We talk about fiber in terms of strand count, because we're not conducting anything, right? We're sending light. So simplex is one strand of fiber, and you can buy simplex fiber in a lot of data center type applications, or if you think about your home, right? People talk about fiber to the home, fiber to the business. Often that's simplex fiber that's being pulled. Once you get past the D mark, right? Once you get into the building, you really never pull simplex. In fact, when people come to us to purchase simplex, our engineering team will, usually give them a call, almost always give them a call and say, what are you doing here? Because the vast majority of applications require, at a minimum, duplex fiber, 2 strands of fiber. And that is because in a networking application, which is where fiber is used the majority of the time now, you will have one strand to send signals and one strand to receive. Now, you don't have to do that. Simplex fiber, one strand of fiber can certainly send and receive. It's just the way you're multiplexing your lasers, the way you're sending your signals back and forth through that piece of glass, right? We make HDMI extenders that use simplex fiber. But if you're truly looking to future-proof, right, and so much about an installation is future-proofing, duplex is what you want to look at, because duplex is going to allow you to use that cable not just for HDMI, not just, for AV, but also for networking, because duplex is the standard in most applications, 2 strands of fiber. Now, in the commercial world, we see multi-strand fiber being pulled, and there's 2 different ways you can engineer your cable with multiple strands. Breakout fiber, that is where we have multiple strands that are fairly heavily jacketed. This is good if you think about like that telephone pole where you're pulling your fiber up and then you're going to break it off to 4 security cameras, or maybe you're going into a broadcast application where you want more, heavier jacketing on those strands of cable. That's where breakout comes into play. Now, the downfall of breakout is that it's a little bit, more rugged. It's harder to bend that cable because you got so much jacketing on. In a fixed permanent installation, typically what we see is micro distribution fiber. Micro distribution is where you've got all those individual little strands of fiber in one bigger outer jacket. In micro distribution, think of this as where you're going from like rack to rack or building to building. This is where when you're doing a campus installation or stadium installation and you're running all of these signals through this big pipeline of fiber, the fiber that's running from, city to city, we're talking about all small micro distribution fiber, albeit with different jackets on the outside of it and, different constructions, but it's still micro distribution with the smaller strands of fiber on the inside. And we are talking small strands of fiber, literally just a little bit bigger in diameter than, most hairs on our, if you think about hairs on our heads, right? 9 micron diameter cables. So how do we work with this in the field? Well, fiber optics, this is not, again, a new category. There's a lot of equipment that we use to break these things out, patch these in the network room, in our racks, wall boxes that break all this out. And the way it works, and you can kind of see this in the image here, we go from one bigger cable, a micro distribution cable that's pictured here in this application. We're breaking out those individual strands and we're running those into individual connectors. And you can do that through what are known as fan out kits. They basically, help you fan out those connectors. Most people just terminate in the field. So they'll take their cable, terminate in the field, or they'll buy a preterm, right? A cable, the diameter of a pencil, can literally have 24 strands of fiber going into it. And if you buy a pre-terminated piece of cable, that's just going to come with all those connectors. They're going to be wrapped for pulling. They're going to be staggered so they can actually go through conduit. I mean, this is not reinventing the wheel. This is pretty standard stuff. But what you're going to do, you're going to terminate, you're going to buy a pre-made, or you're going to go into a fan-out kit, and your rack equipment, your wall box equipment, even your wall plates are designed to handle this. And the big thing that you'll notice here, how that fiber is coiled. It is so important that if you're working with traditional fiber, and I'm going to talk more about this at the end, traditional fiber, you got to be sensitive to that bend radius. These modern fibers, these polymer-coated fibers, you don't have to be as sensitive. I mean, again, 3 millimeter bend radiuses. Okay? So let's talk about the construction types of fiber. There's really 2 that you're going to see. And this is all standardized, so color-coded. You see standardization in the colors of fiber. If it's a yellow cable, it's a single mode fiber. If it's an aqua color, it's a multi-mode fiber. And now you may get into an outdoor rated or a direct burial that's black or white or gray, but if you open that up and you actually look on the inside, odds are it's going to be yellow or it's going to be aqua. Older fiber, you saw like what's known as an OM1. I'll explain that here in a minute. You'll get into oranges and reds and some other colors. But the fiber that we are using today in most applications is going to be yellow single mode or Aqua Multimode. The difference between the two cables is the size of the glass inside. And the size of the glass has an effect on the physical performance, the physics of how these cables work. And it's a little counterintuitive for, folks who've been in the AV industry for a long time, because if we think about, hey, I want to handle more bandwidth, or I want to go longer distance, how do we do that with a copper cable? We get a thicker gauge, right? We put more copper into it. Fiber is the opposite. To get a signal to go a further distance, you actually take glass out of it. In a single mode, that yellow fiber, that yellow cable you're seeing on the screen, that's got a smaller core size. That cable exceeds 1,000-foot max distance. Actually, single mode, you're driving your signals with most, AV equipment that's built for single mode, or networking equipment that's built for single mode, 10 to 20 kilometers, 6 to 12 miles. That's what single mode fiber does. Multi-mode fiber is actually a bigger core that's going to max out at about 1,000 feet. Why is that? So if we think about light waves, right? That's what we're dealing with here. Lasers, waves of light that are going through this glass pipeline. Well, how do they travel through a glass pipeline? These wavelengths, they're bouncing back and forth as they go through this optical highway. And if you've got a big piece of fiber, like a multi-mode fiber, a 50 micron piece of glass, those can start to get out of phase as you start to hit a longer distance, right? So a multi-mode piece of glass, that aqua-colored piece of glass, a thicker piece of glass, that maxes out at about 1,000 feet. Now, you can get more simultaneous signals through it because it's a thicker piece of glass, but you lose your signals. They start to get out of phase at about 1,000 feet. Now, that single mode fiber, 9 micron piece of glass, the yellow cable, that keeps those things in phase, again, 10 to 20 kilometers. You can go longer distances. Now, as you're starting to pick between the two, single mode or multi-mode, you got some options. You're going to see a grading on this fiber cabling. And we have seen some evolution here. So in the single mode world, there's really two different types of fiber you're going to run into, OS1 and OS2. You're not going to see that much OS1 being manufactured anymore. Most manufacturers standardize on OS2, which is considered a tight buffered cable. It's how we build the cable. In a tight buffered cable, basically you're building a single mode piece of fiber, a single mode cable, so it resists, breakage. It's more durable, it's a smaller jacket. That's what we're seeing. OS2 is really going to be your standard. In the multi-mode world, there's some moving parts right here. The one cable that you really want to stay away from, and you can still buy it, but most manufacturers have phased it out, as OM1. This is one of the first multi-mode grades of glass, and the reason you're staying away from it is actually because it's a thicker diameter than OM2, OM3, OM4, and OM5. It's harder to work with, okay? Different sized connectors. You got to adjust your cleaving equipment. Cleaver is what we use to, cut and prep the glass in the cable. It's a thicker piece of glass. You don't pull OM1. If you're going into an installation where there's OM1 already installed, you're going to couple it, go through a media converter, go through equipment. You're going to couple it into OM2, OM3, or OM4. And even OM2, we're not seeing that much anymore. That's because those cables, OM1 and OM2, are LED optimized. Electronics today, they're laser optimized. That is what we are seeing. OM3 tends to be the standard. OM4 gives you more bandwidth capabilities. OM5 doesn't have a lot of practical applications in the AV world right now. Very often, I will get asked the question, so what are we standardizing on, right? You're telling me OS2, that's pretty much the standard. Stay away from OM1. OM2 is really not what I want to work with. Great. So I'm going to standardize with OS2, OM3, or OM4. Okay, that's what I'm going to pull. But am I future-proofing? Am I truly future-proofing here? And the punchline in all of this is, yes, you're future-proofing if you're pulling your OS2 cable, you're pulling your OM3, you're pulling your OM4, okay? Now, it gets a little misleading because when you look at specifications of networking equipment, often you will have a bandwidth rating at a certain distance. Those ratings, those charts, take into account the electronics with the fiber cable. And the simple fact, and I can say this as an electronics manufacturer, this is what we do. We build electronics at TechLogix. It's a big part of our business. Electronics just simply have not caught up to the inherent capability of glass, right? Those optical pipelines have the ability to move lasers back and forth. The electronics, the lasers in the electronics, they're just not fast enough to read yet. By pulling an OM3 cable, an OS2 cable, an OM4 cable, that piece of glass in there has 100 petagigs worth of data, 10,000 times more bandwidth capability than a Cat6 cable. You have a lifetime worth of bandwidth by pulling that fiber optic cable. And this is so important because in these trainings, I am not, here today to tell you are never going to pull a Cat5 cable again. We are still using copper-based cables in lots of installations. We do. You will be using those for years. But to truly future-proof, to prepare your network, to prepare for high-definition video transport, right, you got to think about pre-wiring with fiber optics. You need to think about putting that cable in. When you are pulling cable, you want to be thinking about wiring and designing systems that have that fiber available because you are future-proofing when you put fiber in the wall. A couple of last things that we want to go through real quick here. Connectors, you're going to run into a couple of different connectors in the field. There are several versions, but in the commercial world, in the residential world, there's really two that you're going to run into. LC and SC connectors. They terminate in the same way. They have the same performance characteristic. If you can work with one, you can work with the other. The difference is the physical size of the connector. Okay, LC is the smaller one. This is the connector that you are seeing on most equipment. And that is simply because it's smaller. You can make your electronics smaller. You can fit more connections side by side. SC connectors, they're larger. You still see this on a lot of electronics, but they have been getting phased out. And those electronics that use those connectors, especially when we're talking about the AV world, what are they? HDMI extenders, HDMI control. Look at it this way. All of those electronics that we have worked with for years with Twisted Pair, extenders, switchers, AV over IP systems, you're seeing those variations now in the fiber optic world. In fact, these black boxes look very similar to Twisted Pair extenders. The only difference is you got a fiber connector on there, right? That's with that little blue connector. That's a duplex connector. There are electronics with simplex connectors, one strand. Interesting thing, right? We get into super speed USB. That's an awful lot of bandwidth that we're trying to move. Well, guess what? Fiber is great at moving things like high speed and super speed USB. So you have options here when we're getting into the electronics. A couple of things that I want to leave you with is in the troubleshooting. Anybody who's a technician, anybody who's working with fiber optics in the field, there's a couple of different things that you want to keep in mind here. Real quick, we'll run through this. There's some great videos on the TechLogix website that get into more detail. Also, articles. There's a lot of great online articles. You can search for link budget, for example, learn all about these concepts. But in AV, this is very important for you to understand. So a link budget is something that's going to affect your designing, and it's going to affect your troubleshooting. And a link budget consists of two things. A loss budget, which is how much signal loss you anticipate on a cable run, right? No different than in the copper world. We can look at our installation and say, well, okay, I've got, a couple of keystones. I've got this little splice point. There's going to be some loss from that. Fiber is no different. You will have loss on your cable run. And a power budget, which is the acceptable amount of signal loss that your devices can handle, right? So if I'm using my cable for HDMI distribution, right? Those extenders will have a power budget. They can accept so much loss before they don't work. Now, those power budgets will really vary fairly widely between the different devices out there. The reason I say this is important to AV professionals is because what happens when we have signal dropout with HDMI or DVI or, really any video signal, you see a dropout, okay? You see a dropout in performance, a flicker on that screen. That is considered by us a catastrophic failure. Customers do not want to see their signals, their screens go black, and their equipment resync. In the networking world, okay, what happens when we have dropouts? You just have a slower connection. So the power budget for AV devices, that's usually about 3 dB, whereas in networking, it's anywhere from 11 to 22 dB. It's important for you to understand this when you're designing your systems, because those systems will have different areas of loss, whether it's the connectors, the cable itself, keystones, couplers, all kinds of different things will affect that loss. And this is where in the fiber world, when we're designing our systems, we do a little bit of math to determine whether our system really fits within that power budget or not. So, if we look at a very common CI type application, consumer application here, well, if we're just running a signal, an HDMI signal from a rack out to a projector, and this could really be house of worship, this could really be any application, right? We've got some connectors, we've got some cables, we've got some, keystone couplers in line, some patch cables. Well, we can look at an installation like this and say, okay, worst case, if my equipment's a little bit sloppy, I am going to have about 1.3 dB of loss. And if I'm using this line for HDMI extension, I can tolerate about 3 dB. So I'm fine, right? Expect 1.3 dB. I've got a budget of 3 dB. I'm well within tolerances. I'm well within specs. And any installation where you've got to certify your cable runs, this is part of that certification process. So what do we use to do that? Well, we use VFLs. This is a tool that comes with, most termination kits, most termination hardwares. This is basically a visual laser. So you can see if your connectors are terminated properly. But you also get into test kits, optical test kits, where you can meter out your line and actually get a printout that tells you how much loss is in this particular run of cable. It's all part of certifying. Now, the good news is it does take a fair amount of slop in a system to start to exceed those power budgets, or those link budgets, I should say. Very often, the loss is coming from dirty connections. And I mentioned, you might have caught it before while we were kind of talking about the polymer coatings on the cables. The polymer coating keeps these cables clean now. Okay, so you don't have to clean the cable during installation. But you will notice that when you buy fiber optic equipment, it all comes with dust caps. You keep those dust caps in place as long as possible. And that's because, let's face it, most work sites, there's dust in the air. We have oils on our hands. As you remove those dust caps, you are going to contaminate the optical lenses inside your equipment, whether it's a network switch, a cable, a coupler, everything ships with dust caps. You keep those in place as long as possible. Should you get, debris, dust, oils on your cables, on your ports, in your ports, well, you use cleaners to clean that up. And most people don't realize that there's these really handy little pen style, they're known as click cleaners, that you just literally pop on the end of that fiber cable, push it down, you hear a little click, it just cleaned that optical lens. But this is the number one source of loss in a system: dirty connection points. Be aware of that. And really the last thing that I wanted to mention here, fiber bend radius. Way more powerful to see this in action. When you see these modern polymer fiber cables where you're actually tying them in knots and pulling it with all your strength, trying to get these cables to break, and they don't. But in most installations that you're going to go in, pre-wires that have been done, places where fiber's already been run, you're dealing with traditional fiber. And that traditional fiber is a 30 millimeter bend radius in most installations. You have to be aware of that. And that is not to say you can't work with it. You can. Just be careful as you're handling it. Make sure that you are not exceeding that 30 millimeter bend radius. If you're going into rack equipment, wall boxes, things like that, use those coilers that are part of that equipment. If you are terminating that cable, make sure you're sensitive to, the glass inside of it. If you're doing a new installation, my recommendation, stick with these SSF grade fiber cables. They don't break. There's no shards of glass. They're incredibly durable. This is what's making making fiber very deployable in these AV applications. So with that, I will turn it back over to our friends at FDW.
Oh, thank you, Cameron. Excellent. I was fascinated because now I've seen this before, and I still learned stuff this time. This is great. And some of the folks that have been listening and paying attention at home have also been learning some things because they've asked a few questions here to get a little more clarification. So we'll do a couple of those. Grant wrote in and asked, if not length and wire size, what are the advantages of multimode? So if you could review multimode's advantages.
Yeah, so multimode is going to be the most common fiber type of cable that you're going to see in, most commercial applications, most in what we would call inside plant, inside building type applications. And part of it is because you're not exceeding that 1,000-foot distance. So you don't have a distance concern there. Multimode's an interesting thing over single mode because the cable, because there's more glass, is actually more expensive. The cabling is slightly more expensive than the single mode fiber. However, the electronics that attach to a multimode cable tend to be less. So your total cost of installation on a multimode installation is often less expensive. And that's why we see it being pulled. The other thing is when you're dealing with a lot of inside plant, inside building type applications, you are moving a lot of, simultaneous signals. For example, there's little black boxes out there. There's electronics where you can run all of your audio, all of your video, all of your control, all of your network over that one piece of fiber, and multimode's really ideal for that. So the one thing that I tell everybody, if you're pulling cable, you're not exceeding 1,000 feet, multimode's going to be the way to go. If you are, you got to go to single mode. Stick with one cable in your installation or the other. There's nothing wrong with having a single mode piece of fiber that, only goes 2-3 feet. No problem. Single mode will do that. The electronics might cost you a little bit more, but multimode and single mode do not inherently talk to each other back and forth. They're two different sizes of glass, so you need some electronics to couple the two together. It's easier to stick with one type of fiber or the other.
And then, Cameron, a question having to do with the bend radius, the nature of the fault, I think is what they're shooting at. And what they're asking about is if a cable has been subjected to too tight a bend radius, does it fail arbitrarily as a complete failure, or does it get into an in-between kind of intermittent mode? Does it fracture? And if so, how do you detect that? How do you measure that? How do you deal with that?
Yeah. That is one of the big problems with fiber, right? It does get into an intermediate mode. You're lucky, as I mentioned, if you bend it too tight and it snaps right away, it breaks catastrophically because then you got a bad piece of fiber. Often what will happen is, in these older installations, throughout the course of time and handling, and depending on your fiber grade, even things like the weather, it can have an impact on that glass. And if you get a crack in there, that crack is going to slowly spread over time and gradually decrease the performance of your cable. So here's what I tell people, right? If you got a piece of fiber, clean the ends. If it's not behaving, I should say, clean the ends. Check your connectors, right? Make sure it's terminated properly. If those things are all done and it's still not performing the way it's supposed to be performing, you're just not getting the speed, you're not getting the bandwidth, you meter it out, you see where it is, how much loss on the line. If it is exceeding, your link budgets, it's time to get rid of that piece of fiber. There's really nothing you can do with a cracked piece of fiber other than to get rid of the damaged spot. And you can get equipment that will tell you at what foot length that damage has occurred. Most people don't do that, though. It gets really expensive. It's easier to pull your fiber out, pull a new piece in.
So is that like a TDR for optical, and do they call it an optical TDR, or what is that device?
Yeah, it's basically a meter with a bend a break reading on it. And we use, in the fiber optic world, we call these things meters and light sources because you're dealing basically with laser generated light.
Mm-hmm. In that regard, and this one, I think this question came in earlier, but I think you addressed it. But they were asking about the tools or the recommended tools for an installer that's working routinely with cable, with fiber rather. What would be the recommended tool set? But you did have a slide on that topic, but let's review it.
Yeah, and this is one of the nice things, because it used to be, if you were going to get into the fiber optic world, you had to have clean room equipment. Most people have invested in trailers. At a minimum, you were in at $12,000. It was expensive. Today, we're seeing these termination kits that are going to give you your light source, right? Your laser, all your termination equipment. These things are under $1,000. Testing equipment used to be, that was very expensive. If you wanted to meter out these lines, now you're in it for under $1,000. And obviously, as you want to start to unlock more features, right? I want to get into PC readings and printouts and all that. You'll see the prices get up there, but it's incredibly affordable. In fact, a lot of the fiber optic equipment is comparably priced, if not less than a lot of the copper-based equipment. And that's just because, the cost of the lasers that we're using today have come down. This is also why on these network switches now, you'll see that SFP port. That SFP port is used for a fiber module. These fiber modules, to take your network switches and make them fiber-based, you're under $100 to do that. So it's very affordable today.
Wow, that's changed a lot in the last decade. That's incredible. Well, the last question is probably a real good segue into it too, because the last question deals with that very topic. Basically, where to get the training. Somebody wants to learn to terminate the cables. They want to get their installers all up to speed. Where can they do that? What's offered? Is there anything offered to your company? What are the resources?
Yeah, absolutely. So we're very, very active in the training, and you saw this training today, obviously fairly agnostic. We use different slides from different manufacturers who have contributed to this, over the last couple of years that we do it. We're a training-based organization. So if you go on the TechLogix website, www.tlnetworx.com, networks with an X, you can search for videos. We have a video library, 7-minute video is going to teach you how to terminate. We do workshops. You'll see a training page on our website where there's different locations. We literally do workshops around the world. Most of them are here in the United States in different regional cities. Or you can sign up for one-on-one training. We were talking about this earlier. We have folks on staff that all they do is train integrators. And these one-on-one sessions are nice because, you'll go through, while it's online based, but you'll go through how to terminate, how to work with the cable. It's really quite easy. In fact, you will be able to terminate faster, terminate fiber faster than, you can work with a shielded Cat 6. It's quite amazing.
That is amazing. Cameron, thank you very much. Great seminar today. We certainly will continue to answer questions for people if they write in with follow-up questions or need directions, but a lot of resources there. And speaking of resources, I want to remind people that there are a couple of handouts. Tell them again about the 2 handouts, if you would.
Yep, there's 2 handouts. They're in your GoToWebinar little widget there. One's a nice front-back, 1-page resource that has a bunch of fiber optic definitions. So multi-mode, single mode, talking about the different connectors, the color coding. It's a great resource just as a little cheat sheet to, help you continue to learn about this and pick your different products. And then we have the solution guide. The solution guide is kind of like a easy to follow catalog that'll go through the different formats, go through the different options out there. I will tell you one thing about TechLogix. We try not to make this too big too fast. So while there are literally thousands of different SKUs and variations for fiber, we try to stick with the top common equipment that's being used. If you don't see it in the catalog, give us a call, give your, folks at FDW a call. We can certainly help you out because we're really all things fiber, all the different.
You certainly are. Thank you very much. Cameron, thank you. That will wrap it up for today. And once again, remind folks, please, if you have not done so, do take advantage of the survey. Fill us in on some of your reactions to today's presentation, and if there are suggestions for other ones, we take those seriously, and we try to make these as useful and relevant as possible. And we will certainly respond if you have additional questions for Cameron. We will follow up with him, and Cameron will communicate back through us, or certainly contact him at his company and get some answers for what you do, because this is certainly the direction that more and more of the installations are going to be heading. Terrific. Thank you very much. That concludes our webinar for today.